Okay, what do I have to do for the first one? X to the power of 8. So distribute that 2 in, right? Same question. I just realized that. Okay. How about B? Okay, so tell me what would it be without giving me the answer. So 2 to the power of 4. And 24. Y to the power. Now I'm just going to write the answer as 16 x 24 y 4. Okay? How about the next one? X to the power of 12 divided by y to the power of 50. Can you guys read that? Probably not. Okay. Next one. I did not hear what you said. So how do you get the 27?
3 to the power of 3 is 7.
Okay, so 3 to the power of 3. Y to the power of 6 divided by. So it's going to be 27 y 6 over x to the power of 8. Are we doing this good? Do you guys have the right answer? Okay. How about the last one?
X to the power
I did not hear what you guys said.
x to the power of 2 plus 4 x y to the power of 3 plus 4 y to the power of 6.
That's right. Okay. So this one you have to actually do the FOILing, right? Because I have a sum in the middle. So in order to get that, do it twice. And then you're going to have to do the FOIL. So x times x is x squared. X times 2y cubed is 2xy cubed. 2y cubed times x is 2xy cubed. And then 2y cubed times 2y cubed is 4y6. Collect like terms, the two middle terms are like terms, so they're going to be x squared plus 4xy cubed. So you're adding your coefficients plus 4y6. Are we okay with that? All right. Now,
First we're finding the angle, now you have to do a second short side. And do second short. So 0.7.
I want you to look at this one. We're going to do a couple of them with the expanded, but then we're going to do some of them that are quicker. Okay? So, if you have a cubed divided by a, so if I want to do the expand and simplify, I have to do a times a times a over a. So what do I get? A squared. If I want to use the exponent law, I just do 3 minus 1, which is a squared, right? Are we okay with this? Okay. How about the second one? I have a cubed divided by a squared. So the top is going to be a times a times a over a times a. So if I want to simplify this, so the a cancels. What do I have left? An a. And if I want to use the exponent law, because of division, I subtract the exponent, so 3 minus 2, which is a. How about the next one? 1 what?
A cubed divided by a cubed is 1.
So the answer, your final answer is 1. Just 1. Let's look what. So if I have a cubed, so that's a times a times a, over a times a times a, right? So that is gone, gone, gone. It's 1, right? Because when you divide 5 divided by 5, what do you get? 1. 10 divided by 10, what do you get? 1. Anytime you divide something by itself, right, you're going to get 1. No matter what it is. If it's a letter, if it's a million, if it's anything, it's going to be itself. It's going to be 1, right? So the answer for this is 1. Now, let's look at this. If I use my exponent law, I'm going to get a 3 minus 3, right? 3 minus 3. What's 3 minus 3? Is 0. A to the power of 0 is equal to 1. Anything to the power of 0 is 1. This is one of the rules. Anything, no matter what it is. It could be a billion. It could be a letter. It could be a sentence. As long as it's to the power of 0, it is equal to 1. Okay? And I just showed you what. Because everything simplifies, and then you're dividing by itself, so it's equal to 1. Are you guys okay with this? So, the rule says a to the power of 0 equals to 1. Okay. Let's keep going here. I have a cubed divided by a to the power of 4. So that's going to be a times a times a over a times a times a times a. So if I simplify, simplify, what do I have left? 1 over a, right? I have the a left in the denominator, and in the numerator I have nothing left, so that's 1, right? So that's 1 over a. You guys see that? Because I have nothing left in the top, and I only have 1a left in the bottom. Okay? Now let's use the exponent law. If I do 3 minus 4, what do I get? A to the power of negative 1. So I want you to relate this and this. We're going to look at the next question, okay, the next one, and then I want you to use your, not the next one not going to help me. I want you to look at this one. Okay, forget about these two. Let's look at the next one. So I'm going to write it a to the power of 3. So that's a times a times a. Over a times a times a times a. One more time. Okay? If I simplify, gone, gone, gone. So what do I have left? It's not 2. What is it?
1 over a.
1 over a to the power of 2. It's not 2.
Yeah, that's kind of one.
Okay? Now, let's use the exponent law. A, 3 minus 5. What's 3 minus 5? So that's a to the power of negative 2. Do you guys see the relation here? What's happening?
Negative.
What's happening to the negative exponent? So look here. Relate this and this part.
Well, it's turned into a fraction, right?
It's flipping, turning into a fraction, right? And then what's happening to the exponent when I flip it?
Oh, you're putting on the other side of the equals, so it becomes a negative.
It becomes a positive.
That's a negative.
Yeah, I mean, if I change this into this,
Oh, yeah, yeah.
right? So, what's happening here, anytime I have a negative exponent, I flip my base. So remember that your base here is a over 1, right? To the power of negative 2, right? Anything, if it doesn't have any denominator, it's over 1, okay? So what's happening here is I'm flipping this, so it becomes 1 over a, and then making my exponent positive, so it becomes plus 2. Okay? So let's look at the next one. Now, this one, I'm going to have a times a over this. If I simplify, what do I have? 1 over a cubed. Okay? Now, if I do my exponent law, 3 take away 6 is negative 3. Remember that these two are the same. These two are equal to each other. They're the same answer. Written differently, but they're the same answer. Okay? Now, if I'm going to use the exponent law here, it's going to be a, what's 3 minus 7? Negative 4. If I want to write as a fraction, how would I write it? 1 over 8. Okay? In math, we can't leave answers with negative exponents. So if your answer at the end have a negative exponent, you are required to make it into positive by flipping. Okay? All right. Yep.
A minus 4, you can put it in 1 over a 4.
That's right. That's right. Okay? If you have this, for example, if your answer at the end is a b to the all to the power of negative 4, flip the base, right? Flip the base, that means it becomes b over a. And then plus 4 as the exponent. Okay? These are the same. You're just flipping the base to make your exponent positive. Are we okay with this? All right. I'm going to, I'm not going to do these tests because I've already showed you the 0 rule. The rule says a to the power of 0 equals to 1. A million to the power of 0 equal to 1. No matter what the answer is to the power of 0, it's going to equal. Are we okay with this? And for the next rule, again, we just did the testing, so I'm not going to test again. But I want you to remember that the negative exponent rule, if I have the power of negative m it's the same thing as writing 1 over a to the power of m. And if I have a over b to the power of negative m, that's the same thing as writing what? Okay? This will only work if your exponent is negative. Okay? 90% of the time, you're not gonna, so I'm just gonna show you something here. So if you have this, okay, don't flip until the end. So if your answer at the end has a negative, then flip it. Okay, let's do actually D together. Okay, so let's look at it. So I have x to the power of negative 4 times x to the power of negative 2. I don't want to flip from the beginning. Okay, what do I have between the two? Multiplication. So what do I do with the exponent? You add, right? Negative 4 plus negative 2 is? So you're adding the exponent, right? Because you have multiplication, right? So that's going to give you negative 6. Now this is your final answer. Because your final answer have a negative exponent, now you have to flip to make it positive. Okay? So your final answer should be 1 over x to the power of 6. Okay? Let's do all of them together. What would a be? What do I have to do with the exponent? Add them. What's negative 8 plus 8? So I have x to the power of 0, which is what? 1. X is actually x to the power of 1. They're not the same. Right? So it's not x. It's x to the power of 0, which is 1. What do I have to do with the second one? Subtract. So 10 minus 12, right? What do you get when you do 10 minus 12? Negative 2. And I need that negative 2. I can't, right? So I have to flip the base and then make it to the power of positive 2.
Why are we flipping? Like, I don't get it.
Because remember when we talked about this right here?
Why can't it just stay at negative 2?
Because you can't, it's not a proper format. Okay? It's like, you know, when you're going to a game or whatever, and then like, let's say you can put your shirt on top of your short or under your shorts, and then there's rules like you have to put it under your shorts, tuck it in, right? This is the rules, or you can't play the game. This is the rules to the math. Okay? You should not be leaving a negative exponent. X to the power of 9, all to the power of 0. Right? It's 1. Because x to the power of 9 times 0 is 0. Right? And then x to the power of 0 is 1. What do you think the next one is going to be? What do you do with the exponents? Subtract, right? So that 2 is going to stay there, right? It's not going to change because there's nothing else that I can simplify it with, right? It's going to stay as 2. Exponent for the top is 1 minus exponent of the bottom, which is 3. Right? So that's going to be 2x negative 2. Now, huh? That's right. Which one do you flip? You only flip the one with the negative exponent. 2 is not connected to that negative exponent, right? If it's connected, it will be written like this. It will be written like this.
So you only flip it when it's a negative?
You only flip it when the exponent is a negative,
Okay.
right? So in this case, my exponent is negative for x only, so it's going to be 2 divided by x. So I brought it down to the denominator. You guys see that? In this case, if I have this case, where it's in the bracket, then I have to flip the whole thing and it becomes like this. You see the difference between these two?
I'm lost. No, just that last step, like, I don't understand. Like, okay, so -2, and then where does it go from there?
Where?
Yeah,
Here?
right there.
From here to here? Okay. You see how this is a negative exponent,
Mm-hmm.
right? So technically I have to flip the base, so that looks like this, right? Because the base is x over
Okay, so I'm not
1.
even looking at the 2 right now.
No, we're not looking at the 2, right? So forget about the 2 front, okay? So I have this, right?
Mhm.
X to the power of negative 2 over 1.
Yep.
I flip it, so it becomes 1 over x to the
Okay.
power of 2, right? Now because I have that 2 right here,
Mm-hmm.
right?
Then
Then you just multiply, so it becomes 2 over x. The easy way to think about it is that you have to bring this down to the denominator and make it positive.
So if you're plugging in the 2 for the 2x squared at the bottom, you don't do that?
What do you mean you do plug it in?
Like, don't you have to times it by everything?
That too? Yeah. So you just multiply, this is this, right?
Yeah.
So you multiply this by this by that.
Oh. Alright.
It's not an exponent, it's a function. How about f? Huh? 4 over x cubed.
You just say 4 or 1.
So your answer is 4x cubed? 4x cubed?
The answer is 4.
What's the numerator? What's x to the power of 0? So I have 1 on the top over 4x cubed, right? Can I simplify this any further? Can I simplify this any further? Is there anything else to simplify? No, right? So in this case, it's easier if I get rid of that x to the power of 0, right? Because I know that's 1. I don't have to do anything, right? Okay, it's getting harder. Next one. What's the first thing I want to deal with?
First bracket.
The first bracket, right? Why do I want to deal with the first bracket? It's because it has the exponent, okay? I want to deal with that exponent first. So what do I get if I deal with that exponent? So 5 squared is 25. X4. Y. Instead of writing 25, I want to leave it as 5 to the power of 2. You'll see why. Okay. Now you see the 2 brackets? What's between them? Multiplication. So what do I have to do with the exponents? Add. Okay. So tell me what happens for the 5.
So keep the 5 on the base and add the exponent.
So remember that you're looking at the same base, right? So this is the same base as this, right? So you're gonna have to add your exponent. So it's gonna be 5 to the power of, what's 2 minus 2? 0. Now,
When
you're,
there's no, isn't that a one now?
it is a 1. So we're gonna, in the next one, we're gonna simplify. Then we're gonna have to deal with this. Again, same base. What do I do with the exponent? Add them. 4 plus negative 6
-2?
is negative 2. So what would I get here? Add them again. 4 plus 1 is 5. Now, I'm done with the simplification. Now I have to kind of make it look nice. Okay?
Looks pretty good to me.
Yeah, it doesn't look pretty good to me. 5 to the power of 0 is 1, right? So this I can just set this 1. I have a negative exponent here. What do I have to do with it?
Flip it.
Flip it, okay? Remember, this nothing's gonna happen to it. So it's gonna be 1y5, okay? Instead of this being in the numerator, it's gonna come to the denominator and it's gonna become positive. Do you see that? Do you see that? It's the same as this, where I brought it down to the denominator and it became a positive. Okay. I want you to try the next one.